Alright, in this second video we'll be continuing to review the exam 2 review, or go through the problems. On number 6 here, we're just evaluating a function given input values. So here we're given the input value 0, g of 0. So what I like to do is make a shell for the function. So wherever there was an x, now you see parentheses. And let's go ahead and plug in 0 as our input for x. And so we just need to simplify the right side to get the output. So notice this zeroes out and that zeroes out. You're just going to get 6 here. 0 plus 6 is just 6. Let's do the same thing with negative 4. So let's plug in negative 4. So we just want to follow the order of operations here. We're going to square the negative 4 first. That's 16. And so then we'll multiply the negative 2 and the 16. We get negative 32 minus 4 plus 6. And so you're going to get negative 30 out of that one. Let's plug in 2. So I'll do the same thing here. This time 2 squared is 4. And then we're going to get negative 8 when we multiply there. And then finally you get 0. Letter D is a little interesting. Really, all it's going to do is end up changing our variable. We're going to replace all those x's with p's. And so really there's nothing more to do than to just write it out with p's. Now on number 6 we're going to have a little bit more work. We're plugging in an expression x plus 1. So we'll start the same way. Notice I made my parentheses a little bigger because I've got a binomial that I'm plugging in to replace x. It's okay that this input has an x in it. Wherever we had an x, now we're going to have an x plus 1. So let's just plug in our x plus 1s. And the hardest part here is just simplifying this. Notice x plus 1 squared, that's a binomial squared. We're going to have to FOIL this. So I would multiply the first terms, the outer terms, inner terms, and the last terms. You're going to end up with x squared plus 2x plus 1. So this becomes negative 2 times x squared plus 2x plus 1. We can drop the parentheses on that x plus 1 there. Don't forget your 6. And then we need to distribute here. And again, bring down what we had before. And finally, we can combine our like terms. We got some x terms we can combine. So we'll get, notice I did bring down the minus 2x squared. So negative 4 and 1, we're going to get negative 3x. And then negative 2 plus 1 is negative 1. Plus 6, we're going to get 5. All right, last one here. It says for which values of x is g of x equal to 5. So basically, I'm just going to rewrite the function, but g of x should be replaced with 5. In other words, remember g of x is another name for y. Our y value is 5 here. And so this is a quadratic equation, so we want 0 on one side. So let's subtract 5 to do that. And then the other thing here is, notice my leading term is negative. And if we're going to factor, that's not really what you'd prefer. So there's an easy way to get around that. Just multiply each side by negative 1 here. 0 times negative 1, that's not going to change 0. But on the other side, all three of our terms are going to change signs. That's what happens when you multiply by a negative. And so this is one where we'll want to use the AC method. So we need two numbers that multiply to AC, or 2 times negative 1, which is negative 2. And that add up to our B term. In this case, it's negative 1. And so 1 times 2 is the only way to get 2. And we need these to be opposite and add to negative 1. So the 2 needs to be negative. Now there are no shortcuts to take on this one. We're going to have to split our B term. And we can factor out an x from the first two terms. It's going to be x times 2x plus 1. And we know when we factor these other two terms, we should get a 2x plus 1. And it looks like we need a negative 1 times that in order to make that work. And so we end up with 2x plus 1 times x minus 1. Now remember, we were solving an equation, so let's put that on the left over here. And then we want to set each of our factors equal to 0. So here we're going to get 2x equals negative 1, and then you get negative a half there. If you set x minus 1 equal to 0, you're going to get 1. And so those are our two answers. All right, let's move on to number 7. All right, so we're supposed to find the difference quotient. That's this complicated looking fraction here, f of x plus h minus f of x all over h. So what I had suggested is that you do this in steps. So first of all, let's find f of x plus h. So wherever there was, so the function is going to take 4 times your input and subtract 5. So in this case, our input is x plus h. So we're going to do 4 times that and subtract 5. And we end up with 4x plus 4h minus 5. So now let's find f of x plus h minus f of x. So we're going to take what we just did, that's our f of x plus h, and subtract f of x. Well, that's just 4x minus 5. And so let's go ahead and you can drop the parentheses on the trinomial there. And don't forget to distribute the negative here. And so you get minus 4x and a plus 5. And notice the 4x and the minus 4x cancel, the minus 5 and the positive 5. We get just 4h. So we're just about done here now. We can go ahead and write the difference quotient. We've already found the numerator. It's 4h. Over h, we're going to get 4. All right, let's look at part B. This one's going to be harder because the function is a little bit more involved, a little bit more going on here. So again, we have to find f of x plus h. So again, you can make a shell, and then let's plug in an input of x plus h. So again, there's a lot of simplifying to do here. We're going to have to square x plus h. So we'll FOIL that out. You end up with x squared plus xh plus xh plus h squared. We've got 2 of those xh's, so we're really just adding 1 xh and 1 xh to get 2 xh. And now we can go ahead and plug that in. It'll be 2 times that. Let's go ahead and distribute the negative on the x and the h and bring down the 4. And we need to distribute here. And then again, bring down the minus x, the minus h, and the plus 4. And so that's f of x plus h. So now let's do that minus f of x. So we just found f of x plus h. That's this part here. Minus, let's see, this is f of x up here, so that's what we're subtracting. Now one thing we're seeing is when we do this part, these 3 terms that we're going to get are going to end up canceling out 3 terms from what's in the other parenthesis. So let's finish this out. So I drop the parentheses there. I'm going to distribute the negative here, so all my signs are going to change. And then notice we can cancel out the 2x squared and the minus 2x squared, the minus x and the plus x, and the 4 and the minus 4. So what we're left with is 4xh plus 2h squared minus h. So finally we're ready for the last step, the difference quotient. It's just what we just found over h. And so let's go ahead and write our answer for the numerator there. That's what we just found. And that's all over h. So we can break this into 3 fractions. And let's see, 4xh over h, the h's cancel, you get 4x. H squared over h, that's just h, so we're going to get plus 2h. And anything by its divided by itself is 1, so h over h, that's just 1. All right. This last one really is for those of you maybe going on to calculus or just want something a little more challenging. Hardest part about this one is the fractions, just knowing how to work with fractions. So you know, I'd say this is kind of an optional problem. Could think of it as an extra credit type of problem if I even put something like this on. I'm not even sure I would do that on the test, but so it's a little more complicated. So we'll do the same steps. F of x plus h is just 1 over x plus h. So that was pretty easy. However, f of x plus h minus f of x, well, we just found f of x plus h, that's 1 over x plus h. Excuse me. And then we have minus 1 over x, which is f of x. See, the problem here is these are fractions. They don't have a common denominator. If this were x times h, then xh would be our GCF, or a common denominator. I should say our LCD. But it's not multiplication there. We have to treat x and x plus h as two separate algebraic factors. And so our LCD is just the product of the two. So what we do is we rewrite the fractions so that they have that LCD as their denominator. So for the first fraction there, we're missing the x factor, so we'll multiply by x over x, and we'll get x in the numerator. In the second fraction, 1 over x, we're missing the x plus h, and so we'll multiply by x plus h over x plus h. And so we end up with x minus x plus h. Notice you're going to end up with x minus x, which is just 0, and a minus h. So you get minus h over x times x plus h. And so now we're ready for the last step. And again, we're just running into some more algebra issues because of the fractions. So the difference quotient will be what we just got, minus x over x plus h, x times x plus h. And that's divided by h. So we have a fraction within a fraction. That's what makes this a little bit challenging. So what we're going to do here is just write this using division. So it's the numerator divided by h. And when you divide a fraction by another number, we can multiply by the reciprocal. That's what we normally do. Notice our h's cancel, and we're left with negative 1 over x times x plus h. All right, let's move on to number 8. So these are piecewise functions. So the first piece here is x squared minus 3, and we're going to use that piece when x is less than or equal to 2. So I'm going to go ahead and graph this part, and I'm going to choose values that are less than or equal to 2. Well, let's start with the borderline value here of 2. Notice we have x greater or equal to 2, or sorry, less than or equal to 2. And then for the bottom piece, x is greater than 2. So when we do both graphs, we want to include when x is equal to 2 on our table. So I'm going to make a table. We'll start with 2. So here we're going to plug in 2. We get 2 squared minus 3. 4 minus 3, that's going to be 1. So 2, 1 is on the graph. And it did say that's when x is less than or equal to 2, so we're including that point because that's where we're equal to 2. So we need some other numbers that are less than 2. So let's go with 1. We'll get y equals 1 squared minus 3. Well, that's going to be 1 minus 3, which is negative 2. And so 1, negative 2 is on the graph. Now keep in mind, this is a parabola. We know what this looks like. So we need to get that parabola shape. Let's try another number that's less than 2. So 0, when you plug in 0, you get 0 squared minus 3, which is negative 3. 0, negative 3 is on the graph. We still don't know where the turning point is, but I think we're getting close here. Let's try negative 1. Negative 1 squared minus 3, that's going to be 1 minus 3, which is negative 2. And so finally we've got our turning point here. The graph's going to look like that. So basically we're graphing just the part of x squared minus 3 that's where x is less than or equal to 2. All right, so now we're going to look at the other piece where x is greater than 2. The output in that case will always be 4. So let's make a chart, and notice each time the output is 4, I chose the borderline value of 2, and then I picked some other nice numbers that were greater than 2, 3 and 4. So when we put those points on the graph, we have this line here. This is a constant function, or this piece is a constant type of function. Notice I have an open circle at the point 2, 4. That's because we're only using this part, or this piece, when x is greater than 2, and so that's why we have an open circle right at 2. Alright, let's move on to number 9. So if x is less than -1, we're using this piece here. If x is greater or equal to -1, we're going to use this piece of the function. So if we plug in -1, -1 is greater or equal to -1. It's actually equal. And so we're going to use the bottom piece there. So it'll be -2 times our input plus 3. In this case, our input is -1. We're going to get 2 plus 3, which is 5. On part B there, 2 is also greater or equal to -1. So we're going to again use the bottom piece. It'll be -2, in this case, times 2 plus 3. We're going to get -4 plus 3, which is -1. And then letter C is the same exact situation. 4 is greater or equal to -1. So we'll plug in 4 into the bottom piece. And that's -8 plus 3, which is -5. So it looks like this is the only one that uses the other piece. Notice -2 is less than -1. So we'll use the upper piece, and we just need to plug in -2 here. -2 plus 2 is 0, and the absolute value of 0, well, the absolute value of 0 is just 0. -0 is just 0. Remember, 0 has no sign, positive or negative. It's considered neutral. Alright, let's move on to the next slide. So it says use the graph of f of x on the right, and then we're going to find all these things. So the domain, remember, we want to go from the leftmost to the rightmost point. Notice there is no left or rightmost point here, and we look at x values, but in this case it's going to be all real numbers. For the range, we want to go from the lowest to the highest point. Notice at the lowest point we're at -3. Hold on a second. So here we do have a lowest point, and there the y value is -3. And actually this graph does go up forever, so you should have said -3 to infinity here. Alright, on letter C it says indicate the intervals on which the graph is increasing. Well, first I want to remind you that you're going to be working on open intervals when you do this. Or I should say, when we describe where a graph's increasing, decreasing, or constant, it's always going to be using open intervals of x values. So let's go ahead and get started here. You can divide this graph up into the parts. Notice here to the left of that line, this function is constant. And so basically that's when x goes from -infinity up to -2. And so that's where we're constant. And then after that, notice here in this region we're going to be decreasing. So when x goes from -2 to 1, that's where the function's decreasing. And then you can see after that the function's always increasing. And so, whoops, I'm getting ahead of myself here. So we're increasing. Notice it goes forever right, and so it's increasing there in the green when x goes from what is that? 1 to infinity. All right, so on letter F it says find f of negative 3. So when x is negative 3, x would be our input. Notice that point there is where x is equal to negative 3. And the corresponding y value there is 3. So f of negative 3 equals 3. For f of x, or f of 2, we want to go to where x is equal to 2. So notice this is the point on the graph right here where x is equal to 2. The way I like to think of it is when x is 2, what's the height of the graph? Notice it's down 2. The other way to think of it is at that point there, the x value is 2 and the corresponding y value is negative 2, so f of 2 is equal to negative 2. Alright, on letter H, it says for which numbers x is f of x equal to 1? Well, remember, f of x is another name for y, and so we know that the y values can be thought of as the height of the graph, so I want to look at where the height of the graph is 1, and so that happens right there. And notice there's 2 points on the graph where the y value is 1. So that's going to happen when x is negative 1 and when x is 5. And so that's going to be our 2 answers here. On part I, it says for which numbers x is f of x equal to negative 3. Well, our height, or our y value, is negative 3 now. So we're down 3. So there's the point on the graph right here that's down 3. And that occurs when x is 1. And notice there's no kind of symmetry here. So we should say this is neither. Alright, so let's move on. Actually, we'll stop this video right here.